everyone. This video will be studying about an an electric current and drift velocity. Electric current and drift velocity. Okay. Suppose this is a conductor. Connected somewhat like this. And this is a battery supplying current I to the conductor. Length of a conductor is L. Its cross-sectional area is A. Now, you know that electric field will be set up in this direction. Suppose these are free electrons. They will be experiencing a force, okay, and they will be moving to this opposite direction with a velocity vt. This is what a drift velocity. Okay, now let's say n is free electron density. Okay, A is your cross-sectional area. Let's say now total number of electrons will be n into volume. Volume is what? A into L, right? So total charge on these electrons, it will be total charge will be, just multiply it by E. Okay, total charge delta Q, it is what? NEAL, right? Since charge on one electron is E, so total charge on NAL will be N into A into L into E. Time taken by the drift electron to cross the conductor will be delta T, and this will be what? L means distance moved upon at what velocity that distance is being moved, that is drift velocity. So your current will be the total charge that is flowing upon time taken, means delta Q by delta T. That means N into A into L into E. Okay, this is what? Delta Q upon delta T is L upon Vt. If we move Vt to upward like this, okay, this L and L, okay, this will get cancelled out. So from here you got I is equals to N into E into A into, this is what? Relation between current and electric current and drift velocity. Okay, now I by A can be written as J, right? So this will be N into E into Vd, means current density will be N into E into Vd. Okay, now this is what? A relation between electric current and drift velocity. More number of problems can be designed, okay, by just manipulating this equation. Okay, now note, for a given conductor, current does not change with change in its cross-sectional area. I is independent of cross-sectional area, right? The second note, if a steady current goes in metallic conductor of non-uniform cross-sectional area, then what will be the scenario? Non-uniform cross-sectional area. Okay, this is connected in somewhat like this. Let's say K1 current is I1, E1, J1. Here A2, I2, E2, J2. Okay. The first case, I1 will be equal to I2. Okay, this means J2 will be greater than J1. Okay, and A1 V1 is equals to A2 V2, and you know A1 is greater than A2, so this will imply V2 is greater than V1. This implies V2 is greater than, right? So this was a note you can, right? Now you know that a relation between potential difference and electric current is V is equals to I into R, where R is your resistance. Okay, and this relation is valid for all type of material, right?